Hey everyone! So today we're going to take a concept you probably already know, the good old square root, and we're going to level it up to understand something called nth roots. Now, if you've ever seen a weird little number on a root sign and felt a little bit confused, you're in the right place. Stick with me, and by the end of this, it's all going to click. Let's jump in.
Okay, so look, we all know the square root of 25 is 5. Easy enough, right? But what happens when we change the game a little bit? What if we put a tiny 3 on that root symbol and a negative number on the inside? Is that even possible? Well, that's exactly the kind of question we're going to tackle today.
So here's how we're going to break it all down. First, we'll go beyond the basic square root. Then, we'll talk about the single most important rule in this whole topic. I promise, it's a game changer. After that, we'll run through some examples, I'll show you the common traps to avoid, and finally, we'll even look at why any of this actually matters in the real world.
All right, first up, beyond the square root. And don't worry, we're not throwing out everything you know. We're really just building on a concept that you're already familiar with.
This looks formal, but all it's really asking is a simple question. What number, b, when I multiply it by itself n times, gives me the number a, you see? For a square root, n is just an invisible 2. For a cube root, n is 3. It's that simple. Powers and roots, they're just two sides of the very same coin.
Now, to talk about these things properly, we need to know the lingo. That little n is called the index. Think of it as the boss. It tells you exactly which root to find. The number under the symbol, that's the radicand. And the whole thing together, that's called the radical. Getting these terms down just makes the conversation so much smoother.
Okay, now we're at what I think is the most critical part of this entire topic, understanding why that index is everything. And I'm not kidding, if you get this one idea, you basically unlocked 90% of what you need to know about nth roots.
So here it is, the big rule. You have to look at the index. If that index is an even number, like 2, 4, or 6, then the number inside, the radicand, cannot be negative. It's just not allowed in the real number system, and your answer will always come out positive. But if the index is odd, like 3, 5, or 7, anything goes. The inside can be positive or negative, and the answer will just have the exact same sign. That's it. That's the secret.
All right, enough with the theory. We've got the rules down. Now let's see these things in action and actually solve a few problems.
Let's form up with some nice, clean numbers. The square root of 49? Well, that's 7, because 7 squared is 49. The cube root of 125 is 5, since 5 times 5 times 5 gets you 125. And the fourth root of 16 is 2, because 2 to the fourth power is 16. See? Not so bad, right?
Okay, but let's go back to that question from the beginning. What happens when a negative number shows up inside the radical? This is where that huge rule, even versus odd index, becomes our best friend. Let's just walk through this. The cube root of negative 64. First thing we do, look at the index. It's 3, which is odd, so negatives are totally fine. The answer is negative 4. Now what about the fourth root of negative 16? The index is 4. That's even. Uh-oh, we can't have a negative under an even root, so this is not a real number. And the fifth root of negative 1? Index is 5. Odd. No problem. The answer is just negative 1.
All right, ready to level up again? What happens when we're not dealing with numbers, but with variables, like x? The rules are exactly the same, but there is one tiny extra detail that you have got to watch out for.
So we're simplifying the fourth root of x to the fourth. We see the index is 4, that's even, and we know the rule. Our answer has to be positive or 0. But what if x itself was negative? Say x was negative 2. Well, negative 2 to the fourth power is positive 16, and the fourth root of 16 is positive 2. So to make sure our final answer is always positive, we have to put absolute value bars around the x. It's like a little safety guarantee.
But check this out. When the index is odd, like the cube root of x cubed, life is so much easier. An odd index doesn't mind negative answers. So if x is negative 2, the answer is negative 2. No absolute value needed at all. The answer is just x, whatever it was, positive or negative.
Okay, time for one of my favorite parts. Let's get ahead of the game and talk about the common mistakes and traps that trip people up so that you can just sidestep them completely.
This, right here, this is the #1 error, hands down, forgetting the absolute value when you have an even index and a variable. The square root of x squared is not just x, it's the absolute value of x. Remember that square root symbol always means the principal or positive root. Those absolute value bars make sure that's what you get.
And the other huge trap is trying to solve for the even root of a negative. I get it. It feels like the fourth root of negative 16 should be negative 2. It just seems logical. But if you actually check your work, negative 2 to the fourth power is positive 16, not negative 16. There is no real number that you can multiply by itself an even number of times and get a negative result. It's impossible. So, you might be thinking, okay, I get the rules, but when am I ever going to use this? Well, it turns out nth roots are actually really useful tools for describing how the world works.
For example, in geometry, if you have the volume of a perfect cube and you want to find the length of one of its sides, you need to take the cube root. And in fields like physics and engineering, formulas for things like radioactive decay or how a Wi-Fi signal gets weaker over distance, they often use fourth roots, fifth roots, and even higher. These are not just classroom exercises.
So if you only remember one single thing from this whole explainer, please let it be this. Always, always, always look at the index. Whether that little number is even or odd tells you everything you need to know. It dictates all the rules.
So you've pretty much mastered roots. But did you know that every single root can also be written as a power using a fraction? That connection is the secret to unlocking a whole new level of algebra. So now that you've got this down, are you ready to see how it's all connected? We'll save that for next time.
Thanks for joining me.